let's solve some problems from exponents, powers and surds. Which of the following expression represents the square root of 81 raised to the power of 4? So let's see what is clearly written here. It says that square root of 81 is raised to power of 4, which means that square root of 81 whole raised to 4. So we could actually find the square root of 81, which is 9, and then raise it to 4. But rather than that, I would suggest you to do it this way, which is 81 raised to 1 by 2 whole raised to 4. So it's 81 raised to 1 by 2 into 4, which means that it's 81 raised to 2. So we got the answer as 81 raised to 2. Now moving on to the next question. Simplify the expression 8 square raised to 1 by 3. It's 1 by 3, so it's 8 square raised to 1 by 3. What do we do here? What is 8 square? It's 64 raised to 1 by 3, which means to take the cube root of 64. Now what is the cube root of 64? Let's find it out by prime factorization. 64, so 2, 32, again divisible by 2, we get 16, again divisible by 2, we get 8, again divisible by 2, we get 4, again divisible by 2, we get 2, then dividing it again by 2, we get 1. So we get 2 triplets of 2, right? So we multiply this with each other and we get 4. So 4 is the right answer here. Now let's move on to the next question. Evaluate minus 2 to the power of minus 3. So first of all, any number raised to negative power gives us negative numbers, right? So is that right? No, it's not. So any negative number when raised to odd numbers gives us negative numbers. But what if the power is negative? So nothing other than this, we take the reciprocal of the number, that is minus 2 raised to 3. So we get 1 by minus 2 raised to 3, which is 1 by minus 8. So minus 1 by 8 is the right answer here. Now what is the value of 2 raised to 0? So we know that any number raised to 0 equal to 1. So 2 raised to 0 is also equal to 1. Now which of the following expressions is equivalent to 5 raised to 2 whole raised to 4? This is again the property of exponents, which is a raised to m whole raised to n gives us a raised to m into n. So 5 raised to 2 whole raised to 4 gives us 5 raised to 2 into 4, which is 5 raised to 8. So 5 raised to 8 is the answer here. Now simplify the expression 3 raised to 4 whole raised to 2 divided by 3 raised to 2. So we have 3 raised to 4 whole raised to 2 divided by 3 raised to 2. Let's sort this out first, right? So what is 3 raised to 4 whole raised to 2? Again, a raised to m whole raised to n is equal to a raised to m into n. So 3 raised to 4 whole raised to 2 is equal to 3 raised to 4 into 2, which is 3 raised to 8, right? Now 3 raised to 8 divided by 3 raised to 2. So we have the same basis here. So we have to divide this now. So what rule do we use here? So a raised to m divided by a raised to n is equal to a raised to m minus n, right? So 3 raised to 8 divided by 3 raised to 2 is 3 raised to 8 minus 2, which is equal to 3 raised to 6. So the answer is 3 raised to 6. Now moving on. Express root of 125 in the simplest radical form. So How do we write 125? We could write 125 as 25 into 5, right? 5 5s are 25, 5 2s are 10 and 12. So, we could write root of 125 as root of 25 into 5. Now, what is root of 25? It's 5 and root 5 here. So, we got the answer as 5 root 5. Now, which of the following is equivalent to root 18 minus root 8? So, what do we do here? We have root 18 minus root 8. So, is root 18 and root 8 the simplest form, or is it in the standard form here? No, it's not. Why? Because we actually know that 18 could be written as 9 into 2. So, this could be written as a perfect square 9 into 2. Now, 8 also can be written as 4 into 2, right? Now, 4 and 9 both are perfect squares. So, let's see. 9, root of 9 is 3 into root 2 minus root of 4 is 2 into root 2. So, 3 root 2 minus 2 root 2. It's actually root 2 into, we take root 2 as common, 3 minus 1, which is actually 1 root 2. So, the question should be 18, root 18 plus root 8. So, this all becomes addition. Now, we have 4 root 2 as the answer. So, we got 4 root 2 as the answer. Simplify the expression root 80 divided by root 5. Now, again, it's the matter of simplification, right? So, what can be 80 written as? So, let's see. Let's do the prime factorization here. So, 2 times 40 is 80. 2 times 20 is 40, 2 times 10 is 20, again 5 times 2 is 10, now again 5 times 1 is 5. So, we got 2, and we got a 5 which is standing out. So, we could actually take these two, right? These 2 into 2 is 4 and this 5 as root 5 because it doesn't have a pair. So, 80 could be written as 4 root 5 divided by root 5. So, we could cancel out both of the root 5s and we get the answer as 4. 4 is the right answer. Now, compare the values of root 50 and root 72. So, we have square root of 50 and square root of 72. Which is greater? Of course, the root of 72 is greater. Why? Because 72 is the greater number. Let's see. We have, say, root 36 is 6. Root 49 is 7. Root 64 is 8. And root of 81 is 9. So, when we are talking about root 50, we are talking about a number which is in between here, right? Which would be very close to 7. So, root 50 might lie here, whereas root 72 lies in between 8 and 9, which is here. Root of 72 which lies very closer to these two numbers, which is in between of 8 and 9. So, root of 72 is greater than root of 50. Now, the next question. Simplify the expression 16 raised to minus 2 the whole square, right? Now, we have to simplify it. So, we could write it as 16 raised to minus 2 the whole square, right? What is the property which we can use here? So, a raised to m whole raised to n is equal to a raised to m into n, right? So, 16 raised to minus 2 whole raised to 2 is equal to 16 raised to minus 2 into 2. What is minus 2 into 2? It's minus 4. So 16 raised to minus 4. This now could be written as 1 by 16 raised to 4. Now what is 16 raised to 4? Let's find out, right? Okay. Or this could be done in another way where we take 1 by 16 square into whole square, which means 1 square by 16 raised to 4. Both are the same thing. I hope you understood. So it should be 16 into 16. It's a greater number like 36, 6 1 is 6, 7 8 9, 1 6 is 6, 1 6 5 256. 1 by 256. No, it's not the right answer which is given here. So basically it's again 256 into 16 into 16. So it would be a very greater number which is given here. Now if it was 16 raised to minus 1 whole raised to 2, then we could have written it as 1 by 16 raised to 2, which is 1 by 256. So we could take this value as minus 1. Okay. Now evaluate minus 3 whole raised to minus 4. Minus 3 whole raised to minus 4. So a number is raised to a negative number. So x raised to minus n is equal to 1 by x raised to n, right? So minus 3 raised to minus 4 is equal to 1 by minus 3 raised to 4. So what is minus 3 raised to 4? So a negative number is raised to an even number, which should give us a positive number, right? So these two options are eliminated already. So if we look at it carefully, we could actually spot that it's 1 by 81, because here we have 1 by, and this is straight up 81. So we can't, 81 can't be the answer. So let's see. 1 by 3 minus 3 into minus 3 into minus 3 into minus 3. So minus 3 into minus 3 gives us 9. Again minus 3 into minus 3 gives us 9. And 9 into 9 is 81. And the answer goes 1 by 81. Now, what is the value of 3 raised to 3 into 3 raised to 5? So 3 raised to 3 into 3 raised to 5. This is of which form? A raised to m into a raised to n. The product is a raised to m plus n. We have same basis and different exponents. So this would be equal to 3 raised to 3 plus 5, which gives us 3 raised to 8. So 3 raised to 8 is the right answer. Now moving on to the next question. Simplify the expression 4 raised to 5 whole raised to minus 3. We could do it in both ways here. Again, we could take this as 4 raised to 5 into minus 3, which we would get as 4 raised to minus 15. So it would be 1 by 4 raised to 15. So we got the answer right here, right? Yeah. Now, express 64 as the power of 2. Now we have to express 64 as the power of 2. So what do? We do the prime factorization with 2. We get 32. Again divided by 2 we get 16. Again divided by 2 we get 8. By 2 we get 4. Again dividing by 2 we get 2. By 2 again we get 1. So 1, 2, 3. We are pairing it. We could say that it's either 2 into 2 into 2, which is 1, 2, 3. 8 raised to 3. Should we say that? 8 raised to 2. No, we are not expressing it as squares. We are not caring about this terms, exponential term. We need to express it as the power of 2. So how many 2's are here? 1, 2, 3, 4, 5, 6. That is 2 raised to 6. 2 is multiplied 6 times to get 64 here. Okay. Now, evaluate 9 raised to 5 whole raised to 2 divided by 9 raised to 7 whole raised to minus 1. So first let's use the property a raised to m whole raised to n is equal to a raised to m into n. So by using this here and by using this here, we get 9 raised to 5 into 2 divided by 5 into 2 divided by 9 raised to 7 into minus 1. So 9 raised to 10 divided by 9 raised to minus 7. So what is a raised to m divided by a raised to n? It's a raised to m minus n. So 9 raised to 10 divided by 9 raised to minus 7 is equal to 9 raised to 10 minus 7, because it's negative here, right? So it's 9 raised to 17. Got it? Let's check the answer once again. So we have 9 raised to 10 and here we have 9 raised to minus 7. So what do? We subtract it from each other. Now we get 9 raised to 10 minus 9 raised to minus 7. So 9 raised to 10 minus 7 is 9 raised to 17. So the answer is 9 raised to 17. Now moving on. Simplify the expression 5 raised to 2 into 5 raised to 3. So again, very simple question. A raised to m into a raised to n is equal to a raised to m plus n. So 5 raised to 2 into 5 raised to 3 equals 5 raised to 2 plus 3, which is equal to 5 raised to 5. We got the answer here. Now the next question. Evaluate 7 raised to minus 3 whole raised to minus 2. So what actually happens here? We could do it in both ways, okay? First of all, what is 7 raised to minus 3 into minus 2? It is 7 raised to 6, right? Or otherwise, we could do it as, this is actually, yeah. So 7 raised to minus 3 means 1 by 7 cube. Raised to minus 2 means 1 raised to minus 2 divided by 7 raised to 3 whole raised to minus 2, right? So what is 1 raised to minus 2? It's 1 by 1 square divided by 1 by 7 raised to 6, right? So 1 by 1 divided by 1 by 7 raised to 6 gives us 7 raised to 6. So in the answer there is no 7 raised to 6, but if this is 1, we could get it as 7 raised to 2, which is 49. So if the question is 7 raised to minus 1 whole raised to minus 2, the answer would be 49, which is equal to 7 square. Got it? Now moving on. What is the value of 10 raised to 0 divided by 10 raised to 3? 10 raised to 0 divided by 10 raised to 3. It's nothing. 10 raised to 0 divided by 10 raised to 3. It's 10 raised to 0 minus 3. According to what rule? A raised to m divided by a raised to n is equal to a raised to m minus n. So let's use it here. 10 raised to 0 minus 3 is 10 raised to minus 3, which means that it's 1 by 10 cube. So the answer is 1 by 10 cube. Now express root 12 in the simplest radical form. So root 12. How can we write this? It could be written as, okay, what are the different ways that we could write 12 as product? 1 into 12 could be written as 2 into 6, could be written as 3 into 4, right? Now, which one of these have a perfect square? This one here. See, so root 4 into 3. Root 4 is 2 and root 3 remains. So 2 root 3 is the answer for this question. Now, simplify the expression root 45 plus root 20. Let's see. We have root 45 and we have root 20. How can we write 45 as? We could write it as 9 into 5 and 9 is a perfect square. So we could write it as root of 9 into 5. And 20 can be written as how? We need a perfect square, right? So 4 is a perfect square. Now multiplied by 5, we get 20. So what is root of 9? It's 3 root 5 and it's 2 root 5. So when we are taking the sum, we get root 5. So the answer should be root 5. Now compare the values of root 36 and root 48. So again, it doesn't have to be compared. So it's basically square root, right? Both have the same radical. And this is the greatest number, so this is the greatest answer. Now, express root 75 in simplest radical form. So, we have root of 75. And how can we write 75 as a square root? We know that 25 have a square root of, it's a perfect root, right? 25, 5. Now, we can multiply 25 3 times to get 75. So, we could write it as root of 25 into 3. So, this is 5 times root 3. So, it's root 3, no, yeah, 5 into root 3. It's opposite, it's root 3 and 5. 5 root 3 it is. Now, simplify the expressions root of 98 minus root of 18. Now, root of 98 minus root of 18. How can we do this question? Let's see. So, we could write this as root of 80 plus 18. Is it fine? And we could write it as root of minus 18. Cool. Now, we could write this as root of 80 plus 18 minus root of 18, right? So, what do we do from here? We actually do this in a different way. How do we do it? We have to take the multiple of this, 98. Prime factorization, 2. 4 2s are 8, 1, 8, 9, 7, 7, 7, 1. So this is 7 root 2. Now, what is 18? Prime factorization, 2, 9, 3, 3, 3, 1. So again, 3 root 2. So we have 7 root 2 minus 3 root 2, which is equal to 4 root 2, right? So, what can be written as 4 root 2? Is anything over here complementing as 4 root 2? Let's see. So, root of 80 minus root of minus 18, root of 80 plus root of 18, root of 80, no, root of 116. Let's see something. So, what is 4 into root 2, right? How can we do this? Let's take the 4 inside of the root. So, what does it happen when we take it inside of the root? We multiply it 2 times. 4 into 4 into 2. That is root of 16 into 2. That is the root of 32. Right? So, we need to find a value which is really close to 4 root 2. Let's find out what root 80 is. 2, 40, 2, 20, 2, 10, again by 2 we get 5, 5 again we get 1. So we get 2, 2, so it's 4 root 5, right? And it's 4 root 2. So what is root 18? We said that 3 root 2. So what is 4 root 5 minus 3 root 2? And what is 4 root 5 plus 3 root 2? It's already greater than 4 root 2, right? Now let's check about 116. So 2, 5 2s are 10, 8, 2, 2 2s are 4, 1, 8, 9, and we just have 29. So we have 2 root 29. So which one is very closer to it? 4 root 2, it's 4 root 5, so the answer would be root 80. Now, which of the following is equivalent to root of 27 minus root of 12? So what is root of 27? We could express it as root of 9 into 3, and we could write it as 3 root 3. And what about root 12? We can write root 12 as root of 4 into 3, which could be 2 root 3, right? So 3 root 3 divided by 2 root 3. Root 3 and root 3 would be cancelled and the answer would be 3 by 2. Now, evaluate root of 144 into root of 16. Now let's find what is root of 144. We're doing prime factorization again. So 2 times it's 72. Again 2 times it's 3 2s are 6, 1 2, 6 2s are 12. 2 times 1 2s are 2, 1 6, 8 2s are 16. So 2, 9 2s are 18, 3, 3, 3 and 1. So 2, 2 and 3, right? We're finding the square root, so we are taking pairs of it. Now 2 into 2 into 3, it's 2 2s are 4, 4 into 3 is 12. So root of 144 is 12. And what is root of 16? We know it, it's 4. Root of 16 is 4 because 4 into 4 is 16. Now what is 12 into 4? 12 into 4, 4 2s are 8, 4 1s are 4. It's 48. So is there 48 in the answer? No, there is not. So let's see what is the root of 160. 2, 8 2s is 16, 0, 2, 40, 2, 20, 2, 10, again by 2 we get 5, 5 and 1. So we have 2 into 2, which is 4 into 2 into 5. So we have 20 into 2, 40, right? So we have around 40 here, 40 point something it would be there, so but it's around 40, right? Now let's try about 2304. I don't think it would be the answer. Why? Because 2304, when we are factorizing it, we get a very large number. We just need 48 here. So 2, 1 2s are 2, 1 2s are 2, and 1 0 5, 2, 2, 5 2s are 10, 1 5, 7 2s are 14, 1 2 6, then 2, 2 2s are 4, 1 7, 8 2s are 16, 1 6, 8 2s are 16, again 2, 1 4 4. Now this we know that it's 12, right? 144 is 12, 24, 48 and 48 into 4. 8 4s are 32, 4 4s are 16 and 19. It's 192. It's a very great number. It's a very huge number. So 12 into 4 is basically what? 12 into 4 is 48. And which is the number which is closer to it? Root of 160. So we choose it as the answer. Now compare the values of root of 100 and root of 121. Again, root of 121 is obviously greater than root of 100 because root of 100 is 10 and root of 121 is 11. So we get root of 121 is greater than root of 100. So let's move on to the next question. Express root of 98 as a mixed radical. That is, it should contain both rational and irrational number. So a mixed radical is a radical which have both rational and irrational radical. Let's do the prime factorization. So 2, 3, 4 2s are 8, 1 8 9, 7, 7, 7 and 1. So we have a pair of 7, so we take 7 and we have only 1 2, so we take it as root 2. So it's 7 root 2. Now simplify the expression root 64 divided by root 8. So what is root 64? Again, prime factorization. 2, 32, 2, 1 2s are 2, 1 2s are 2, 6 2s are 12, 2, 8, 2, again 4 2s are 8, 2, 2, 2 and 1. So 2 into 2 into 2. So 2, 4, 8. We have root of 64 as 8 here. And what is root of 8? Root of 8 is, so 2, 4, 2, 2, 2 and 1. It's 2 root 2, right? So 8 minus 2 root 2 is the answer. But still, we could do it in some other way. How? So 64 raised to 1 by 2 minus 8 raised to 1 by 2 divided by 8 raised to 1 by 2, right? It have the same radical but different this thing. So yeah, this does not follow the rule a raised to m divided by a raised to n equal to a raised to m minus n. Why? Because the bases are different. So here the answer would be 8 divided by 2 root 2, right? So it's 8 divided by 2 root 2. So we know that we can write 8 as 4 into 2 and we could write it just like 2 root 2. Cool. So 8 here, 8 could be written as 4 into 2 and 2 root 2 can be written as 2 into root 2, right? So we could cancel out both the 2's from here. Then we have 4 by root 2 left, right? So again, 4 can be written as what? 2 into 2, again by root 2 is here, and 2 can be written as root 2 into root 2, and we have this 2 here, we place it just right here, and root 2, we cancel this out, and we get the answer as 2 root 2. Now moving on to the next question. So, compare the values of root of 120 and root of 128. Again, root of 128 is greater than the root of 120 as the number inside is greater. So this is the right answer. And these were a few questions from the chapter Exponents, Powers and Surds.